All right, yo, what is up, everyone? Welcome to week 84 of working on my own operating system. Yeah, let's get this going. Let me just set up some stuff. Like, get the music going as usual. All right. So that's going. Yeah, today gonna be doing a bit more of the C++ standard library kind of stuff. Let me send out a message in the Discord. Give me one moment. Ping streaming more stuff. And so maybe Clang format, sort of a little tiny thing I want to do today, but in general, we're getting pretty close to having the base project infrastructure being completed. And I don't know, this is sort of what I had in mind for a lot of that. We got our standard libraries, we're using modern toolchain and all that kind of stuff. And there's just a couple things left before we can kind of get going on the actual kernel. So yeah, Clang format assertions are some of the main things that are still outstanding. 0. Yo, vpool, what is up? Get my chat widget all set up on the side screen. Nice. Okay, one second. I'm going to turn off my screen for quickly. Okay. And we're back. Okay, cool. So, yeah, what's on the menu for today? I have a few ideas, but so a couple of things we could do today. ETL, and so we got ETL working last time. ETL is the embedded template library. And there's a lot of cool stuff in there. And I don't really know how to use any of it. So that's sort of one thing that could be kind of interesting to try using. It's now September. But I also sort of, we're gonna run into that eventually maybe. I just wanna do some other stupid stuff like get Clang format working on the code base. But I think one of the interesting parts about today's stream is we might start to delete a lot of the JOS code, actually. I think it's sort of getting ready to be that time. That's a bit of a prerequisite for assertions. Yo, Bacon, what's up? Nice to see you. Hope you're having a nice day or morning, wherever you are. Assertions. In general, basically, we're super close to actually kind of starting on the right of the OS. So what I might start out with doing is I might merge, this branch. I might just kind of review this branch and merge the CPP STL branch, since that's pretty much finished. Okay, sounds like a good plan. When I'm review and merge CPP STL branch, then maybe do a small amount of playing with ETL. What are the interesting types, classes we can use? And I hope you are too. Yep, good day. It's a very good day. Yep, and then, okay. Getting ready to go to church. Nice. Cool. Appreciate it. Yeah, always welcome to pop in for as small amount of time as you want. Clang format. I think from my YouTube analytics, the average view time is like 2 minutes for these things. So yeah, people be popping in. And also that's what I do when I look at streams. I'm usually just popping in, checking things out quickly. Clang format, and then delete JOS user space code. This is sort of, or maybe the Clang format happens after deleting the JOS user space code. Let's try it roughly in this order. So that will be the plan for today. 84 week, that was very inspiring. Thank you. It's just too much fun. All right, let's begin. Let's review and merge the CPP STL branch. So for the uninformed, for a while now, I've been working on adding some C++ standard libraries to be available with the operating system. And these are kind of special because they're freestanding C++ standard libraries. Meaning you can use them on bare metal, which is what we're doing. There's no OS support needed because we are the OS. And so my branch has some commits. This is unrelated, but it's just random, using C++ 23 because why not? Okay, so then adding freestanding CXX headers. This is the first of the STLs. This is basically just a packaged up version of libstud C++. And that's a project from Minsky, who made Limine bootloader. So I'm using this project. And the main reason I'm using freestanding CXX headers is because the two other STLs I want to use actually do depend on some of these standard headers. Like in particular Frig, which we'll look at in a couple commits. This is a very cool library, but it's not 100% freestanding in my opinion, because it does rely on some of these base headers. So first we add the base headers. And this, so first I added the headers, and the way I'm doing dependencies is I'm just adding the code straight to my repo in a third-party directory. And that's pretty much it. But then to get it actually building, I needed to do this kind of hack and renamed this static assert thing because that was conflicting, whatever. Maybe I won't explain these all like in so much detail, but basically in general, using freestanding CXX headers and then doing a bit of a test, using one of the headers, in particular the atomic header is one that that's one of the main headers I would be interested in using. So and we tested a bunch of other C++ features purely using freestanding CSS headers. Now on to Frig. So Frig is this other library that has a bit more functionality than the plain freestanding CSS headers, and added it, and we're trying it out. And I actually did a fix, which I actually upstreamed. So technically we could update the dependency to now use the latest main, but honestly that's kind of boring and not really that important. So probably not going to do that right now. Okay, moving on. This is also kind of random, and I'm gonna move this commit to the beginning of the branch, because this is a kind of a random commit. That's also, it's just another random toolchain thing. So I'm just going to move this all the way down, and I'll probably just, it's a bit faster to do this way. So yeah, okay, so that commit actually goes closer to the beginning of the branch because it's like just kind of a random one-off thing. So, okay, so then after Frig, okay, this was also kind of a random commit that I wonder where this, I think, oh, okay, conflicts, sort of. I think, all right, I'm just gonna do it. Few conflicts. This is sort of stupid. Test.cpp. So what's the conflict? The overload's up here now. So basically, okay, so actually I think I just need, so the difference is, okay, so the difference between the middle and the top is that Frig array got deleted, so I apply that to the bottom. I think I just delete the entire thing. I think that's the conflict resolution here. Sort of similar. Why did that happen? Okay. And yo, what's up, Digitalize? Nice. Have fun cleaning. Dude, I need to clean so bad. My place is a mess. Okay, so what's up here? So difference between the middle and bottom is a Frig array got added, so we add that to the top and accept. So that was good. I think I'm resolving this right. Yeah, what's up, useless? Test many C++ features. Okay, so so now we're just code reviewing this branch and cleaning up the branch, and then this is my C++ standard library branch. So now, wait, where'd it go? This commit can get squashed into, so this is the commit that adds the overload.hpp and uses it, and we can just squash this one down. Cool, okay. Disable W error for now. That was a bit of an unfortunate thing we needed to do. Okay, I have 2 ways it gets open. Actually, no, my like tab situation is kind of like going crazy right now. Okay, I was doing some frigs. Okay, so let me get back to a sane working. Okay, let's just see. we have these errors. Well, they're warnings. And this is all going to go away once we start deleting a lot of the JOS code, and it's not something I want to really spend time fixing. But in order to keep the code compiling, I needed to relax the flags. So we don't have W error now. But we can, I'm just add a comment to re-enable this. Re-enable this when we delete the JOS code. Okay. And I will just amend that into this commit. Okay, cool. So then lastly, ETL. ETL, so we added it. There were a couple patches needed to get it to compile, mostly because it assumed some headers were available that I don't have available. And actually these are candidates for upstreaming. But again, that's like a little bit boring to do on stream. So unless people really want to see me do that, might just not do that. Okay, and then this was some random stuff to get ETL compiling. And actually there's some AI generated code. And then some other random stuff, blah, 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 try using ETL. So I would call the branch good now. I'm just going to force push it, but there's no real reason to do that. And I'll just check out to main. And this is kind of interesting. Okay, when I'm on this branch, there's nothing, then there's a bunch of dirty stuff here. I wonder what happens if I just merge. Yeah, it's all clean. So check out, nice branch, nice history, all merged. And we'll just go ahead and push that. Okay, cool. And just to make sure, like, still building and running. Okay, nice easy start to the day. Get the pen out, check. All right, yo, what's up, Afnan? Nice to see you, man. Okay, small amount of playing with ETL. So that's kind of interesting. That would be kind of interesting to try. And let's pull up the ETL docs. So I did a bit of this last time. So ETL is interesting because it has a lot of static containers. So fixed size containers, no dynamic allocation, and there's quite a few of them. Almost 9K. How did that happen? That dang, wow. Yeah, Afnan, you've been here for a minute. You've been here, I don't know, for like, yeah. Afnan was one of the first people tuning into the stream, I feel like, probably April or March of last year, I think. Crazy. I try not to think about numbers too much, though. I don't know. So maybe just concretely, let's try using a map. That is a fixed capacity map. So get out and apparently I was already trying to do this actually last time. ETL map. So map is like a hash table sort of concept. I mean, I don't know how it's implemented under the hood, but associative container, right? And make this a bit smaller. So the thing that's interesting is the size argument. Like, what does the size mean here? And maybe I'll just fire up my Claude in the background. And I'll just ask it the question. I'm just curious. I'd like to use an ETL map, C ETL in the third party directory. What's an example use of this type? Just curious, can it do this? In the meantime, so basically you pass it some types for the key and the value, some size. I don't know if that's bytes or like what that is. It might even be bytes, maybe. And that's like kind of it. So let's make this a bit more general. Let's call it, let's get, I don't know, 256 or something like that. And then ETL pair, interesting. So that you can initialize the map this way. And so let's say I wanted to do that. And this is all about, sorry, where's the constructor? So you construct an empty one, you can construct one from another iterator apparently. So operator brackets. I don't have to digitalize if you're watching. Got the operator bracket on the map in here. And does it have the normal semantics? If the key does not exist, then one is created using the default constructor. If the map is full, that emits a map full. What does this mean? If asserts, then undefined behavior occurs. Okay, interesting. I think we're not using either of those. All right, let's just try that out. So ETL map, and we're gonna say 42 equals 100 or so, right? And bound contains. So let's just, yeah, let me try to also iterate through iterator, random access iterator. I'm just going to each ETL map. Okay. Each, is it first? What is the actual type of this thing? An ETL pair, probably, right? But it's not a pointer, it's this thing, so each.second. I might just add a couple things to this map. Just see if we can do that. Looks like our Claude finished. J chemo. All right, did that work? 2, 1,000. It's sorted. Interesting. Yep. Okay. 3, 142. Okay. Cool. All right. We got a map. That's cool. I didn't really want to implement my own map, so it's kind of neat. So what APIs do we have? Find. Count, all of the typical STL stuff. What about insert? So yeah, there we go. So let's say we wanted to not use the bracket operator because that's super bug prone. Let's try to use the insert here. And so yes, ETL pair, and it's going to be like 9988 or something like that, right? Let's try to go. Does this work? Yo, what's up, JB? $99.88. So our other way of inserting is working. We can also probably omit this too and just construct it like this. I would also expect this to work. Yes. It's also working. It's kind of cool. But the thing that's a little bit concerning is this map full thing. What is map full? Also, let's check out what Claude said. ETL map create ETL make pair. Interesting. Basically the same thing as what we just did. Access elements, look for things, iterate through the map. Okay, so we have like a basic map. What I'm kind of curious is about this size. It says 10 elements. Is that really true? But that would make more sense than having the size be in bytes. Bytes would be like kind of weird and very arbitrary. So let's bring this down to 1. So now we're going to be overflowing the ETL map, and let's check out what happens if we do that. Probably, okay, so now it like crashes, which is pretty much exactly what we expect because it was saying you're going to have undefined behavior if you insert into a full map. I'm just going to search for map full to try to see what so this is a some kind of exception type, but it sort of seems like it actually would raise an exception. We don't have exceptions, so I'm actually like a little bit surprised it's about that. Overview. Actually, I mean, we can literally look at the we can attempt to find the source. ETL error, okay. let's keep it moving. So got the map working, that's pretty cool. What else can we look through? I mean, having asserts enabled probably is useful. I just want to, just want to go into third-party ETL upstream so I can grab a little bit better. Calls the error handler, then throws an exception. So we don't have exceptions though, so calls the error handler, then asserts. I wonder what happens if I enable this. Log errors. Okay, so now, now we're back in the world of it not compiling. So now we're asking to log errors, and because we've opted into this, it now requires an assert function. Maybe. Okay, it seems like, yeah, it requires assert to be available from assert.h. So we could technically add one. Let's even try that. Actually, this might be an interesting exercise. So I'm going to go into my base lib and go into include and touch assert.h. And oh, inc. Yeah, but inc, this is like this weird one. But to be honest, actually no, it's like this sort of does work. It actually does define the assert macro. So, let me just try to hack it quick. I'm just going to copy inc assert.h into base include. Okay. Now we're running into some undefined symbols because now we're starting, now assert.h is there, and this thing is starting to require some. Let's check that. This is error handler 175. Mm-hmm. Just gonna, what are release? This might actually be for exception support. What's up, Rada? How do you start a side project without feeling overwhelmed by what you don't know? Probably, I would probably just recommend choosing something that's not too far outside your current abilities. Like a little bit outside your current abilities. But yeah, not too far. Then hopefully you don't get too overwhelmed. What's up, Brain? Can you hack 99 nights? Probably not. Don't even know what that is. Okay, this thing is thread safe initialization of local static variables. Okay, this is kind of interesting. So this is the underlying mechanism that allows thread safe initialization of local static variables. Interesting. I don't really understand this well enough, but that is, but it might be useful to be able to use statics though. So there's a couple options here. We could implement stubs that kind of do nothing. Or we could use the compiler flag, or just not use this language feature. Interesting, yeah. Maybe for the moment we just use this flag. I mean, this is like kind of sketchy, and maybe we'll produce a bunch of bugs in the future. What's the comment? Not safe and should be removed, but allows us to use statics. So just curious, now what happens if I try to compile? So it's still doing that crash thing. I'm not sure what kind of assert I was expecting. Use assert. Okay, wait a sec. So currently we're opted into this code, I think. But if we have the use assert function, and is this? Okay, let's just try adding this to the CMake. private error handler. Okay, I want to avoid spending too much time. Right, that's what we just did, right? Use assert function. No member. And namespace ETL. Whoa. So it seems like we're missing. Let's just start with this one, private error handler. Somehow it's, oh wait, but no, it's like this is taking precedence maybe, so maybe you need to delete this. Let's try this. There we go. That's looking a bit better, ever so slightly. So now we have ETL integrated with the assertion handling part of JOS, which means ETL can assert now. And we do not get a useful message at all, but at least it asserts and halts the system and doesn't do that undefined behavior reboot thing it was doing. So that is sort of a small and weird win. 274. It just assert. Wow, what? It'd be kind of interesting to try to step through this, actually. I'm just curious about that. Let's try to do that. So actually, where do we want to break? 2, 3, 5. Okay, so check it out. So we have a capacity of 1. So we have inserted 1 element. Now it's time to insert the second element. And I'm just going to step without. Okay, so here we are. And let's just check this out in the code. Map.h9 at 42. So we're at the ETL assert. And this expands to private error handler. Assert blah 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 function pointer blah blah blah. With the error. So then it's all about this thing. Let's just step one more time. So we're in the is full. So let's just print. Can we print? That worked. Size. Does my tab completion not work? Okay. kind of unfortunate, but okay. So we're here, we're gonna return back, I'm gonna step again. So now we're in this map full thing, which is what we're seeing here. It's this map. So what is ETL error? That's this interesting thing. It takes what seems like a class name and then instantiates it with a line number. Okay, so now we're constructing this quote-unquote exception thing. I'll just step again, step one more time. And now we're just at the assert false. So that is not super helpful. Because it just, like all we see is assertion failed false. A little bit nicer would be to see this actual text here and even some like line. Yeah, ideally we want to see like this line basically, but it's just all kind of it's just asserting false in that one place. Just out of curiosity, I mean, it might be useful to invest a little bit into actually getting good exceptions working here. If we plan to actually be using ETL, which I'm still kind of hopeful for. It's taking a bit of work to get it working, but it's kind of interesting just to learn about this library. And I don't know. So basically the problem is this B thing does not get passed further along. Assert function. Or maybe you're meant to customize this. Private error handler. And also, again, for some reason, my highlighting seems to be very wrong. Just to test that. Like we're almost certainly running this code right. Yeah, and it's like all muted and stuff. Or what can we, I mean, is this cert is included here? Let's just try something kind of crazy. Let's just assert B. So now I'm just like calling the assertion macro straight up rather than doing this slightly weird and convoluted thing. So if I just do this, look at that. It's a little bit better. Now it points us to, so at first it actually prints out the reason for the assertion. And it also points to map.h942, which is the actual place in the code that we want to point someone to if this ever fails. So yeah, I think that's going to be the way to go for the moment. Search. I think that was worth looking into, because otherwise ETL, when we actually start using ETL, it will just start crashing if we sort of misuse it. But now, now that we have assertions rigged up, it should assert. Just quick read through here. Maybe quick read through of this thing. Again, error handling. Error log. Use assert function. So that's the one that we ended up using. I see. Yeah, I was weirdly trying to use two options, but you have to choose one of them. If none of the above macros in the library will use assert. Okay. And then it describes these macros. Oh, wait, whoa, this is interesting. You get the ETL exception. And so actually, so we could also patch this technically somehow. And the question is, what is in the ETL exception? I wish I could, okay. A low overhead exception based string type reason file line. So if we go back over here, ETL error, this thing takes the, and then ETL error, is that an exception? Verbose errors. That sort of sounds nice, actually. Still not seeing where it forwards the... This B thing is super special and important. I don't know why it's called B, but it's the reason that or the Boolean maybe. Yeah, that's interesting. It like loses the reason, it looks like. The reason is right here, but then it constructs the map full. Oh, interesting. It packs. Oh, interesting. it creates the exception type and uses this random string, even file ID. Oh, wow. Okay, for the moment, I think this is good enough, though. So, cool. I'm just gonna make a new branch. ETL assert. All right, this is officially a bit weird with like the copy pasted assert.h somewhere, and I can't see this anymore. So the question is, do we need this thing now? The thread safe statics. It would be nice to not use this. Nice, we do not need that, okay. I also realized we did not have the break timer. We'll take a break right after I sort of check this out. So, the test code. Got this, and we do not need that line. So we're gonna add use assertion function. So these three can go and commit. Enable assertions, actually. Now ETL will use a JOS assert when an internal invariant is violated, e.g. a full map is inserted into test ETL map. Okay, cool. Oops. What is going on? Okay. Okay, let's take a quick 20 seconds. Be right back. Yo, what's up, Prem Yadav? All right, cool. Damn, we got 15 people in the chat. That's cool. All right. So now ETL is in a bit better shape, a bit more integrated, a bit more usable. I'm going to not use one here because that would actually crash things, but yeah, no, don't really need. So now this thing is back to working, hopefully. Yes. Cool. Okay. Got a bit of map action, and we're about halfway through the stream, so I don't know how much, yeah. We will probably be able to just like get to these when needed. There's quite a lot of stuff here. I mean, lists are kind of useful. Maybe it's worth checking out how to use a list. So this is the linked list feature. Shared pool. Okay. Okay, let's just try out a list. Wait a sec, there's like a couple different options. So there's the list, the forward list, the intrusive forward list. Real quick, what is forward list again? Is that, is it only? Yeah, these std containers are just like standalone, and a lot of them, or even all of them, use some kind of internal storage for their elements that is statically allocated up front. So yeah, there's no dependencies really. Std forward list, okay. Okay, so this is just a linked list that only goes forward. Okay, let's say we don't care about that. Okay, let's just do the normal list, and then we'll see about the intrusive one. So the way you use this is with a type and a size. So I'm gonna start making functions for these. List test, or maybe test list. Okay, this function's getting a bit unwieldy. Okay, so struct, I don't know, call it list data, and we'll give it an int, a float, and what about an ETL string or something, my string, something like that. And let's say we wanted to make a list of these things, a list of these structs. So apparently it's something like this, except we need to specify a number of elements, such as 32. And then what? And then you just do like the normal list stuff, maybe. I'm just gonna I find this a little bit easier just to read and get a sense of the functions, but push back, classic C++ container function. Or maybe even emplace back, since we don't have one already. And then we can do 42, 4.2. Okay, I don't know about this ETL string, but hello. Just curious. I mean, yeah, if this compiles, then it works. I don't have that much experience using the ETL string, but this is just a string that can contain a string of up to 32 bytes or something like that. Oops. So far it seems like it is compiling. Yes. So yeah, we can just kind of do this all day. For one. All right, so now we're just appending to the linked list. Yeah. Yo, what's up, Ismail? Nice to see you. Thanks for joining the stream. Checking out this linked list, ETL linked list. Apparently there's some functionality to use this pool, a shared pool or a pool or something like that. Yeah, maybe we'll use that, not quite sure. Then it has all this normal stuff. Push back, push front. So I guess what's a good linked list test? It's like removing an element from the middle, right? Is one of the reasons you would, if you're doing that a lot. Pop front, pop back, insert, erase. Okay, then there's some non-standard functions, I think. Remove if, interesting. Sort, reverse. Right, so what would be a good test? ETL giving us trouble slightly, but not so much. Just kind of looking at what's available to us and trying out some more of these types, but it's sort of working. We were trying out the hash map / dict type, or just the map type earlier. That's working. Checking out this linked list right now. So yeah. All right, so what's the, just to try this thing out a little bit, I guess what I want to do is I want to remove an element from the list. I want to make a list with a bunch of things. I want to iterate through the list to locate a certain element, and then I want to remove it. And it already comes with this remove function. Remove if you pass in some function or something. Actually, you know what? Probably it would be interesting to try to use an algorithm. Do they have algorithms? Like a find? I'm just gonna grep for it. ETL find if. It's exactly what I'm looking for. Maybe it's over here. Didn't really see it. Utilities? Algorithms. Okay, that's what I'm looking for. Find. Find if, let's say. Yeah. Right, okay, so here's what we're gonna do. We're gonna make a list with a bunch of elements. We're going to find if to locate a specific one of the elements. Then we are going to remove that from the list. That's like a pretty basic example of just kind of running through the things you might do with a linked list. Okay, so ETL algorithm.h find if. Cool. All right, let's run it. So we're going to make our list of a couple things. Let's just make 4. I don't know, what's a good number? 25. Hello 2, hello 3. Okay. Now we're going to algorithm to ETL find if. But wait a sec, is that no? It takes, yes. So we do mylist.begin, mylist.end, and then just auto element. And then let's say we're going to look for the element. Let's say we're going to look for the third one where the float is. Well, comparing floats is always kind of tricky. Maybe let's make it a bit easier. Let's look for the one where the data is 25. So we're going to return true element dot a equals 25. And we get an iterator back. And then we're going to check if the iterator is the end. So if it's not mylist.end, so that means we found something. We're going to remove it from the lists. And it's, look, I even have the right, so that's how you just pass it the iterator of the thing. And then let's just check it out. So what is this? Iterator to iterator. Just convert from a const iterator to an iterator. Interesting. But here's hopefully where the real core of this is. Join previous node next. And then here's where we get into the real linked list type of programming. Left.next equals pointer to right, previous.next is left. And we have successfully disconnected the element from the linked list. And then destroy the pool object. And so because it's all static allocation, you don't necessarily free the memory per se. I guess you do. But you definitely need to destroy the object. So what does this do? Pool release. This calls the destructor of the element, but it also calls the release. Okay, so it basically frees the element. Okay. Anyway, this is all in that library code that I'm pretty grateful to be able to use. And then now let's just write a little function that prints the list. I'm just going to make it a lambda just for fun. We can even take in the argument. Okay. auto each list and this is our classic formatting thing for the moment, is how we print stuff using our new frig library, this kind of weird double call thing. Okay, and we're just going to literally do the same thing we did down below. Okay, I'll just do a little hello kind of thing. Printing list. Cool. So now we're gonna initialize, we're gonna print the list. We do our thing, and I'm just gonna say, but why is that? Oh, wait, because I need to pass the list, obviously. Okay. Is this a compiler error? Oh, but wait a sec. Okay, so now. Okay, so yeah, this is, it's not first.each, it's each.a, b, c, or and each.myString.data, I suppose. Is how I'll print that out. Sync is undefined. How is that? Oh, sync is down here. Okay. I'll just make my own sync right here. Yeah, Ismail, they implemented a lot of it. So it's not 100% compatible, but the idea with this library is to make it as close as possible to the normal standard library, so that if you have experience with normal C++ programming, you should be able to use this fairly easily. And I think that's pretty much true. Or I think they pretty much did. In my experience, like this is all, this kind of code is very, very normal C++ standard library programming that you might do. You would just use std find if instead, but like these functions and stuff are all quite similar. But it's not, but to be clear, it's not all. The normal C++ standard library is huge, and that's like a massive understatement. It's incredibly monstrous, and this is ETL is way smaller than the normal one. Okay, so we're gonna print it before and after, and I'm just gonna add a print that's like found the element. Okay, also what's up Insta headshot? Okay, so let's just compiles, let's run it. All right, check it out. So I just need to admire this a little bit. Check out our nice format printing without any printfs or anything like that. That looks pretty nice. So printing list, this is our initial state of the list. It's these 4 items, 42, 4, 25, 9. And these are in a linked list. And then it found the element, then it removed it. So we no longer have this one with the 25, it's gone. And the thing that I'm just very pleased about is that we're not mucking with like next and previous pointers and stuff like this. We're using like an actual data structure and an actual abstraction with this library. So I find that pretty nice. Hey Regil, nice to see you. Okay, so a bit of list programming. And just as another test, let's check out what happens if we overflow the list, because these lists have fixed capacities. So let's just make the capacity 2. And my hope is that we're going to see an assertion that like crashes the kernel. And we see it. And it's not, this is what we were looking at earlier, it's not the prettiest assertion just because of the way ETL is working right now. But ETL is configured to use the JOS assertion panic handler. And so ETL is going to see that, okay, the list is full, but we're trying to do an insert again into a full list. So it triggers its internal assertion, or it triggers its assertion, which calls and forwards to the JOS assertion. And then what do you see? You get told, okay, ipool 587 false. Okay, and you're like, what is that? Let's just quickly take a look at ipool.h. Okay. And then we're like, okay, nice. I wonder what we would see. Like, realistically, the code we're interested in is that like push into the list. But that probably is visible. Let's check out, let's see if that's visible in the stack trace. We're gonna go into the debug, LLDB, and if I just continue, it hits, oh, what? So yeah, that like kind of didn't work. I wanted to see a backtrace, so I can link it back to the actual code in test.cpp. Process interrupt. Okay, so now wait a sec. So yeah, so now I interrupted, and I can do a BT. And I can see that it is currently, it entered the kernel monitor as a result of panicking. But before that, check it out. If we go back, I mean, we can use L to list the source code. Then we can use the up and the down commands to go up and down in the stack trace. So I'm gonna go down. So let's just check this out. We're going, no, wait, we gotta go up, never mind. Up. So now we're just kind of navigating through the stack trace. Check it out. So that is this ipool blah, blah, blah thing we just looked at. We go one more, never mind. We go like a couple more. Okay, now we're like in the middle of the library, which is like not very readable, but now check it out. Now we can link that back to the actual, it would be the OS code, like the client OS code that triggered the problem. So that's pretty cool. Definitely POG, definitely POG. Okay. Okay. I don't know why this, I don't know why the microphone thing is turned on there. Okay. Hit some keyboard combo. And while we're here, it would be pretty cool to check out the intrusive, oh wait, intrusive? list. I'm looking for the word intrusive, and I do not seeing it. Intrusive list.h. So the regular list is cool, but when we're doing OS development, as far as I'm aware, we really want intrusive lists. And apparently there's some support for that. And pretty much the only difference, I mean, just like, as the way I think about it, the difference between the regular list and the intrusive list is that in the regular list, we have this list data type. And it's possible to create a list data that's like not really related to the actual linked list where it's going to be stored. It's just like this object that contains the three things that we decided to put into it. And then if you want to use it in the ETL list, you need to allocate some kind of list node that actually has the pointers, because that's like a very important part of, if you want to be in a linked list, you need to have these like next and previous pointers. And our list, the data type, does not have those pointers. It just has the three things. And so internally, this like list, ETL list or like std list or whatever, it needs to have an internal like node type that has the pointers, and then it also puts the normal data into that node also. And the consequence is that if you have one of these like random objects and you have a list, like a normal list, and you want to put your object into the list, you need to do a copy into, you need to allocate one of these nodes with the pointers and then copy into the node or move into the node. Be right back for the 20-second break. Okay, so I can just quickly try to illustrate this a little bit. Let's just say we have our it's like this object A, and let's say we have our list, and I'm just gonna like, this is what a list looks like, obviously. We have it's like our list data, but the thing is, you can only store like list nodes here, right? And the list node, so we have the list data, which is like our normal struct. What's up, Curiosity? Dude is grinding. List data, and then the list node is basically going to be a list data, and then a list node. I don't know why it's so skinny, but list node prev list node next, right? But this is like internal to the library. From a user's perspective, all we see is the data struct that we care about, that we instantiate the template with. But in the actual list, you can only store these things. And so let's say you want to have, let's say you just have this object and you want to add it to the end of this thing. You have a list data, but you don't have a list node. And so you need to allocate a list node, and like allocate memory somehow, and then sort of like copy from here into there. And that's, it requires you to have a dynamic allocator. Also, what's up to the other person on the board? Let me Yeah. You need to like allocate memory. It's annoying, and you need to copy. And so an intrusive list tries to solve this problem. And it does this by making a trade-off. And so instead of having these two things be separate, instead of having like your list data type, which is like a totally just plain struct, and then this internal list node, you only have one thing. And basically the way it works is that instead of just having a plain object, you give up the ability to only have a plain object that doesn't have the pointers, and you basically just force the pointers to always be there in the object. And so it becomes impossible to just create a simple list data that doesn't have these linked list pointers. And so then you basically make a bit of a space trade-off. So now you start packing these pointers into every list data. But if all of your list datas are eventually going to be stored in the lists themselves, it's a good trade-off, because that means you no longer have this separation between the two different types. You just have the one thing, and it basically you just have like, you know, your int a or whatever, and then you just have like the prev pointer, the prev and the next right there. And this is super common. And then like if you're doing C programming, I mean, it's pretty often just to see straight up people just put the pointers. I mean, that's actually how a lot of JOS works. It's like literally just these like objects, these structs with like pointers. But then once you go into C++ world, you can do it a little bit nicer, or you can make it a little bit cleaner. What I'm trying to say, you can abstract it a little bit better, where instead of directly declaring it with these pointers, you can make your thing inherit from some kind of base class. And that is my understanding, although I haven't seen how it actually works here. I could be wrong. Wait. It is T value is a type that contains the actual values. It is derived from T-link. Okay, I don't like totally get it, but you can kind of see the idea. You rather than declaring the pointers, like somehow you just inherit, and the superclass includes the pointers already. And so then now your type, it's no longer this like standalone type. It like actually has these pointers embedded to it. But the consequence is that you no longer need to allocate and whatever. So yes, performance and I mean, it's also just like if you just don't have a memory allocator or something like that, then it's just a lot nicer to, if you don't have a dynamic memory allocator, then yeah, it's just nicer to not have to worry about allocating the new type. Like literally what happens, instead of allocating the new object and copying it in, you literally just point the last thing all the way at the thing that you already have. And that's it. You've added it to the list. It's that simple. And you can only do that because you made the trade-off that you like always stash the pointers in every single object that might exist, just in case you want to like put it into the list and have it participate in the list. But the idea is that you probably always want like do, basically. So, and so yeah, it sort of like optimizes things a little bit. And I don't know. So it might be kind of cool just to try to do that. So let's do that. Let me port this example to an intrusive list. I'll just copy the code. Test intrusive list. Okay. Intrusive list data. Yeah, made the whiteboard available. Yeah, feel free to join me on the whiteboard. Okay, so trying to use an intrusive list. And it's like, so sorry, containers, let me jump in. And yeah, this is one of the things that does not exist in the normal standard library. I don't know why. I think from what I understand, they were super fashionable, but like sort of went out of fashion and for some reason. But I think they're still quite used actually. I know Chrome has a intrusive list type. I know they're very common. Okay, basically, let's just start. It's basically the same t value and t link. And okay, so check this out. This is actually very interesting because unlike the normal list, basically all of the data structures we've seen so far that I've used with ETL, it's like the array, the string, the map, and the normal list, they all take this size argument for the static allocation that they just like allocate. I mean, it's like internal to the struct, I think. And it's very interesting that intrusive list does not have a size argument. And the reason it doesn't have a size argument is it doesn't allocate. The reason these other things have a size argument is because they all have this like big internal buffer, which they kind of draw from as you use the data structure. Like if you add things to the string, it consumes the internal space. If you add things to the map, it consumes this internal space. Like the thing that is like ultra swag about the intrusive list is it doesn't allocate. And so it doesn't need a size argument because, like I just displayed, it never allocates. If you are passing in a thing to it, you as the client of the thing like have already allocated this somehow, and the list doesn't care where you got that. And so that's like an interesting, subtle detail that stands out. Okay, so intrusive list.h. So let's add our intrusive list. No longer need the size type, but t value and t link. So this is where I don't know how to use this. The default was bidirectional link. And so I'm going to make a guess. An ETL bidirectional link is a struct that contains 2 pointers, basically. And I don't know what's up with the 0. Intrusive links, okay. Okay, made my big guess about this struct. And and check it out, there are 2 pointers here in this struct. Interesting that it ID. Okay, it's like sort of weird. I don't know exactly what's going on there, but yeah, basically the concept is that you have this bidirectional link. Okay, it is derived from t-link. T-link is the link type for this list. Okay, let's just ID it. So apparently you can give it an ID somehow. I'm not totally understanding that yet, but let's just go for it. I'm just going to make my intrusive list data. I'm going to inherit from ETL bidirectional link 0, and I'm going to make this intrusive list data also bidirectional link 0. For some reason you need that 0. It's like a little bit weird. And let's see what I got wrong. Or maybe I did need to... intrusive links. Okay, let's see what I got wrong there. T-value and then T-value derives blah. C intrusive links. Multiply inherited. Okay. Bidirectional link. Okay, but let's just check it out. So basically this is like what I did. It's exactly what I did actually. And then you have the intrusive list with the item. And then as far as I can see, this is exactly what I did. Okay, let's just try to compile. It seems like it probably won't for some reason. Oh, wait. Okay, intrusive list. Okay, I cannot spell that word. Okay. So we got the intrusive list. And pretty much the same thing. Okay, so this is also an interesting and subtle detail about the intrusive list. And so with the normal list, it makes sense to have an in place back. So there's like push back and then there's in place back. And they're like, this is like a big point of confusion for like people that are learning C++, like what's the difference between these two things? They both add something to the list, but push back is for when you already have an object and then you want to like add it to the list. And place back is for when you don't have the actual object yet. You want to like in one operation construct the object and add it to the end of the list. It's like a bit of a subtle semantic difference. Right, and so pushback is for when you already have the actual constructed object, you want to add it to the list. And placeback is for when you have like the ingredients to make the object, but you don't have it yet, and you want to do it in one move, like make the object, put it in the list. And people like debate about like what you should use, blah blah blah. And it kind of matters, but yeah, good to know. But it makes sense to have both of these things there. But now let's like think about for the intrusive list. And I'm seeing these squiggly lines for in place back. I used in place back because I didn't like have the object. I wanted to make them and add them in the same operation. But here, I kind of want to do the same thing, but intrusive lists, they don't make objects. That's like the whole point of the intrusive list, is it's not trying to be responsible for making an object. Like they're all about requiring you to already have a completely valid and well-formed object that has the pointers and everything, and you just pass it in. That's my like guess as to why it looks like this. So I'm also going to guess that it does have pushback. And so intrusive lists are not in the business of creating objects for you. You need to do that yourself, and so that's why there's no in place back. And so here we're going to use pushback. And now we need to change a couple of things because so now we need to actually have the objects. And in more of like a real life scenario, I mean this is like very much not a real life scenario, but you're supposed to like already have the objects available. And I could just like construct them immediately, but that's not really how you use intrusive lists. You're supposed, like the objects really are supposed to have their own like allocation, like memory allocation and lifetime. That's sort of managed externally to the list. And so I'm just going to emulate that right now by putting them all on the stack. So I'll just do lm equals intrusive list data. Okay, and then I'll do 2, 3, 4, and I messed it up. And so this is interesting because now I can't construct my object. I can't construct it this way anymore. So I might need to add a constructor, which is a little bit, what's up, Mohammed? Intrusive list data, a float, b TL string 30. Okay, it's a little bit weird to have to put that size in there all the time. My string. And I'm just kind of sketching this out. Okay, so for the real pro formatting, you apparently put the comma right there, so they all like line up. Okay, my string. Time for the 20-second break. Be right back. My string. Okay, so, and we can even std move this thing. Although actually, LVM formatting is not, yeah. So the std move is kind of funny. I spent all this effort adding like my freestanding CXX headers so I could have std move and like whatever. But then you actually lose all the benefits of std move as soon as you start using these static containers, because you can no longer cheaply transfer ownership from one to the other without copying the entire thing, which like is a bit of a bummer. Std move and like moving as an optimization really only makes sense if like your types don't internally embed all of the data, but are rather like, you know, pointers to dynamically allocated data. That's at least my understanding. There might be some like extremely exotically sophisticated mechanism for somehow sharing it, but I don't really see how that could even be possible, because the whole point is that this new thing, like the old thing will basically get destroyed or no longer contain the data. And so to transfer the data from here to there, you literally need to copy it. Yeah, I'm not quite sure. I'm curious to go as long as I can without writing my own memory allocator, my own dynamic memory allocator. And I don't know, we'll see. Like, I'm just interested in that kind of school of design thinking, like avoiding dynamic allocation. There is this ETL pool type, and I think I probably will use that, but that's not really what I'm talking about. That's more like just like this big pre-allocated blocks of just like all the objects need to be the same size. It's like a pool allocator. It's not like a traditional dynamic memory allocator where you can allocate arbitrary lengths from the allocator. Anyway, okay, so now we have this thing, and I actually, so this is what I'm talking about. I mean, I'm basically exactly writing this example, but look, here he or they, or I don't know, the developer is allocating a bunch of these things just on the stack, and then you just push back. And so I'm trying to do that same thing. And I'm not like, what is this double? Is that real syntax? No way, that has to be a typo. Okay, so now I have my constructor, and I should maybe be able to, yes, so now we're no longer pushing back these things. We're pushing back our LMs, and 2, 3, 4. And I don't know, I'll just distinguish the strings a little bit. Or maybe I'll add it, I'll call it, okay. Intrusive, intru, hello 3, okay. So now we have our intrusive data. So these are like these structs, and the intrusive list does not care about where they're allocated or their lifetime or like anything that's like externally managed. And we're just doing it on the stack, and we're just pushing them back, because that's the perhaps only way. Push, it's just all about these pushes. I mean, you can insert, obviously you can insert into the middle, but you need to have the value type, yeah. And I mean, we're not really going to see anything too spectacularly different, but check this out. This is kind of interesting. So we now have this intrusive list, and we put a bunch of things into it. But then I copy and pasted all that other code that like finds something of a specific data, and I delete it. And even though I changed the data type, like I originally wrote that code against like the normal ETL list, which is basically very similar to the STD list. All of that code, this code at the end, does not need to change at all, because this code just works on generic containers of like basically any type, actually. And so that's an example of why containers in C++ are kind of nice, because you can write code that operates on a container in a very generic way without being concerned about the low level details about like how it's implemented, like whether it's a list or a vector or an intrusive list or a map or like whatever this thing is. So, all right, so I don't know, let's just, oh wait, shit, not. So that's not like, I mean, that's not like a deeply insightful thing. That's like how, that's just like C++ core concepts. But that's how that works. And this failed because I did not increase the capacity on the previous one. And also I probably need to call the test intrusive list function. Test that I'd probably test intrusive list. I be steady misspelling that word. Okay. All right. I mean, like hopefully this should be very boring, but now so this is like the old one. This is like the new one. Printing list. We got our intrusive lists with the 4 things, and in terms of memory, it's just going to be these 4 objects on the stack that just kind of like point to each other. But they could be like in real life, they could be arbitrarily spread out through memory as like the pointing the linked list, right? And then it finds the 25 element and removes it from the intrusive list, and that's pretty much it. So that's like kind of cool just to go through a bit of these exercises and actually make use of the ETL, which we worked so hard to get building. But I think it's really kind of starting to come into like, I don't know, like come into its form. And I can like literally, I mean, if we want to get very concrete, let's just find a place in JOS that has a list, and there's like a million of them. So there's like there's like the environment. I mean, the environment struct is an example of an intrusive list. Check it out, struct blah, blah, blah. And then right here, we just have the linked list pointer straight up in the struct. So, I mean, that's really all it is. It's just you put the pointer in the struct. And in terms of like C programming, it's like a very natural thing to do because you just don't have facilities to do it like in other ways very easily. And so you just put the pointers in the struct. So as an example, and we could absolutely use an ETL intrusive list for this, hopefully, I want to say. In this case, it only needs a next pointer. And so we could maybe even just use, I don't know, like there's like this forward link thing. And so if we cared about that, that's more just a memory optimization. Another one would be the page allocator. And I'm failing to remember where that is. It's like page init. Yeah, so the page allocator, also classic example of a intrusive list. How do I see pp link? Page info. So the page allocator is this, it's just kind of like this array of these page info objects, and the object basically doesn't do anything. It stores a ref count, and that's like it. And then it just has this link. And so I could also see us, if we wanted to like re-implement JOS and like really do it exactly, we could probably use the ETL intrusive list also. And so that's kind of why the intrusive list is a bit more interesting to me than the regular list is if I wanted to actually port JOS into like modern C++ with ETL, I would not be using the normal list type for this kind of thing, because that's different semantics. I'll be using the intrusive list. Plans for testing when placing chunks of JOS code in C++. I don't, because I actually don't really plan to do that actually. I don't really plan on, like, even though I just said theoretically porting JOS to modern C++, that's not actually my plan in practice. I'm more planning to get rid of JOS like entirely, or as much as possible, and start from scratch with more of the with this like super modern, beautiful foundation or whatever that we slowly have been building. But if I wanted to gradually port JOS to modern C++, yeah, it would be a great idea to have some tests. And I mean, actually, if you, I mean, Ismail, you've been around quite some time, so you might remember some of these streams where I was working with these grading scripts from like the MIT course. And basically those are just like unit tests or integration tests. And those would be a perfect candidate for a way to test things. I think that the general principle is, it's just like the OS isn't really structured in a way where it's super easily unit testable, although there were these like check functions that sort of tried to do that. But a lot of the actual integration tests, they just operate on the basis of the serial console like output, and they just more kind of like observe like the whole system and pass. So they somehow pass certain data into it and try to observe that the right things are printed on the console. So that would probably be the strategy there. But I'm going to get rid of that. I'm going to delete probably all of that, I think. And probably that's coming up very soon. I mean, yeah, my idea is to take probably the concepts from JOS, maybe, I mean, not all of them, but conceptually some of the concepts from JOS, but implement it from scratch myself using modern C++. And the only reason to conceptually take the concepts from JOS is because that's sort of all I know. that's just what I learned. So it's sort of what I'm most familiar with. And so at least for a first start, it's gonna make the most sense probably. So, okay, let's check in on how we did today. Review and merge the CPP STL wrench, nice. Small amount of playing with the ETL, done. And that's pretty much it. So I'm gonna wrap up the stream, but like next time, I think literally next time I'll just delete a lot of the JOS code. There's not really that much more I want to do with the JOS code base. It was useful to kind of get all this base project infrastructure set up. But at this point, we're pretty much done with a lot of that stuff. The few remaining stragglers, like I want to have good assertion support, and maybe some unit testing, or not really even this, but like clang format and assertions. This is both of these are topics that like it makes more sense to do after deleting a lot of the code. It doesn't make sense to like format a bunch of stuff I'm going to delete anyway. So yep. So yeah, not all of JOS. So first I'm just going to delete all the user space code just to like kind of simplify things, because I'm not really even like using a lot of it basically. So all of user space is going to go away first, but we're going to keep the kernel, and then we're going to and then probably trim away a lot of the kernel that we don't need. And the parts that will remain are just going to be things like the early boot process, some of the x86 support files, like there's this function that has some helper functions for doing IO ports, like using IO ports. And those are just kind of like functions that are just useful to have. And then maybe like the console driver or something like this. But basically my intention is to return the state of the OS all the way back to how it was like in the very first JOS lab, where it like sort of barely boots up and like kind of, and like that's it. And then from there we kind of can go and gradually like rebuild things from there. All right, word. So that is going to be it for today. Here's my Discord link. Feel free to join the Discord. And that's it. We'll get back into this next week then. So hope you have a great week, and I will see you in the next one or on Discord. Peace, y'all. Have a great one. Thanks, Ismail. Appreciate you as always. And yeah, have a great one. I'll see you later. Peace.